Hello student, welcome again to Power Electronics. This is Raid Al Malki. Today inshallah we will explain lecture number 9. Before we go to lecture number 9, we need to make sure something very important. That we already finished the rectifier يا شباب. We finished converting from AC into DC. This is called a rectifier, as we explained in lecture number 1, right? And we have seen static, we have seen many types of electronic switches, and also we finished from uncontrolled rectifier, single phase, half wave, full wave, three phase, half wave, full wave rectifiers. And also we have discussed in week number in lecture number 7, 6 and 7, we explained the controlled rectifier, single phase, half wave, full wave, and three phase, half wave, and full wave again. Now, after doing the rectification, now we will go for the DC, something called DC chopper. Now, today, inshallah, in this lecture, we will discuss the basic principle of a chopper, and we will go through the buck choppers principles and the circuit explanations. Also, we will discuss the waveforms, output waveforms, and we will see some example, and we will solve it together. Now, lecture number 9 talks about the buck chopper converter. Now we are converting from DC into DC, right? So we are going to outline introduction about the choppers. We will go for buck chopper, and we will see some example. Now, as a start, we need to understand what is exactly chopper, right? What is exactly chopper? So chopper are power electronic converter that convert input DC into output variable DC. So if we have 100-volt DC as input, we can vary the output voltage by stepping down the voltage. We call it buck يا شباب. And if we are going to step up the voltage above 100 volt, then this is called boost chopper. Now let us concentrate on the buck chopper first, right? And as I said, buck is stepping down the voltage. Now this is in DC, right? Remember shabab, in AC system we used to use a transformer in order to step up the voltage or step down the voltage, right? So this is the same concept here, but this is in DC. Now this is in DC. We no longer have a transformer because transformer is working on AC circuits only, right? Here in DC, in order to step up or step down, we call it buck and boost, we need to use chopper, right? Now, let us understand first what is the signal, right? What is signal? Now, if you concentrate here with me, shabab, now let me use a red color. Now this is the shabab here. This is our converter. Now this is our converter. Now we are converting from DC, right? This is DC into DC, right? So this is our signal. Now this is the input here, shabab, voltage. This is the output here. This is the basic principle, shabab, of DC chopper. Now, as an input, I can choose blue color. Now this is VN, right? So our VN is like this, shabab. So this is a value here, right? So this is a value here. This is V input, VI, DC, of course, right? Now as an output, if we get this signal, if we get this signal, right, then V out here, we call it buck converter. Okay, converter. Now, if we get this signal from the output, شباب, we know that the output is here plus minus, and this is the input, right? Plus minus. So if we get this signal, شباب, okay, this means this V out, we can call it boost, because we are boosting what? The output voltage, boost converter. Okay, now as you can see here, شباب, here we have V in, let's say 100. Okay, here we have V out as 50, so we are bucking the voltage down, and here as an output we have, if we want to increase the voltage, then this is called boost converter. This is called boost converter. Okay. Now, previously, for the previous topics that you have taken from the subjects before, we know how to drop the voltage, right? Something called voltage drop. Now, in order to explain voltage drop, this is very easy, okay? But it is not efficient way. Now, let us see here. Now, this is our supply, right? This is our supply. This is supply voltage DC, right? We have plus, minus, Vn, of course, Vn. Now this Vn is having here in series with it resistance. Okay, and here we have V out, right? This is V out. Now this is a resistor with a value of 5 ohm. Let's say the Vn is 10 volt. Vn is 10 volt DC, of course, right? How much will be the V out? Now, in circuit 1, we know that if the current here is 1 ampere, let's say the load is 5. Yeah, let's make the current here is 1 ampere. Okay, right? So 1 ampere here, right, shabab? So 1 ampere. Now, if we multiply to find VR, shabab, here, so VR is equal to what? 1 multiply 5, so it is 5 volt. Now, how much V out? V out, we know, is the Vn, right, minus VR, right? So Vn is 10 minus 5 ampere, so it will be 5 volt. Now, can you see here, shabab, something? Now, we need to step down the voltage as a DC from input 10 volt into 5 volt. Now, where is the lost 5 volt? Okay, 5 volt, we lost we lose the 5 volt in the resistor here as a heat, as a form of heat, and we have lost the power here. So half of the power is lost in the resistor. So as we know, now we can decrease or we can step down the voltage from 10 to 5 using resistor, right? And we can vary the output voltage if we use rheostat or something we call it regulator, right? In this way, this is not efficient because we are losing power here, shabab. We have voltage drop on the resistor, and this voltage drop is very huge. Let's say 50%, right? Here we have 50%. So the problem here, shabab, we will lose half of the power in this way. So this is not practical. This is for a small circuit. If we have bigger circuit, then the losses is very huge, right? So it is very huge. That's why we do not prefer using the old-fashioned circuit here. So we will use something called power MOSFET. We will use the chopper by doing the BWM. Remember, shabab, in the lab we have taken, we are using switches in order to switch on and off, and we are controlling the on time and the off time of the switches. Then we can control the output voltage, right? Now this is the best way, and the losses there will be less than here, of course. Okay, So the efficiency there may be 95% for the buck, 85% for the boost. So and this is fine. But here يا شباب we have 50% efficiency. So this is very huge losses here. Now you can take the screenshot here for my explanation here, right? Or maybe I can keep it. I will go to the next slide here. This is our converter, right? DC into DC. This is our input. This is our output here. So this is VN. This is V out. Plus minus here, here plus minus. So we are converting DC DC. Now, if we use PWM, pulse width modulation, right? If we use a chopper, then the signal, the input signal will be like this, شباب. Now this is the input signal, the same signal, شباب. Now the output is like this. Will be like this. So we are taking part by part, right? This is the output. Now we have problem with this output. This is not pure DC output. It's not straight line. So we do not prefer this way, because in this way, in order to get straight line current, we need to use high inductive load. Okay, high inductive load. Let me write it here. High inductive load in order to smooth the current, in order to smooth the outer current like this. Okay, and this is not practical because we cannot use inductive load. The load is fixed, so it is not easy to increase the inductive load. That's why we do not use it. This is called PWM. This is the this is we do not prefer it because but it's still, it is better than the previous circuit because there is no potentiometer here يا شباب. We use switches to switch on and off. Now we can use better circuit. Now let me just go back to the previous slide, and I want from you to read this part يا شباب. Read this, okay? In order to understand the buck converter, and then we can go for my explanation here. Now, after that يا شباب, let me just introduce to, we need another circuit. We need to think about another circuit in order to get a straight DC line, right? Now, see this circuit. This is a low pass filter. I will introduce to you low pass filter, something called low pass filter. Now, let me take this here. Okay. Okay. I'll put it here. Now, a low pass filter is basically an inductive load. Okay, inductive load and a capacitive load here. Right, this is point A. We have plus here, minus here, and point B as an output, plus here and minus here. Right, now let us explain the low pass filter. Now this is a low pass filter. It means that it will allow low frequency. Now let us see here. Now we know that this is XL, right? And this is XC. We know that XL is basically 2 pi, well, let me write it here. 2 pi FL, right? And XC is basically 1 over 2 by FL. Now, in case of low frequency, now this is called low pass filter. Low pass filter. Now, in case of low frequency, means this F here يا شباب is low. What will happen to the impedance here? What will happen to the impedance here يا شباب? If this one is low, the frequency is low, so the number here will be less, right? So the XL here will go down. If XL is go down, the current will go more, right شباب? So the current here will go more. So it will allow current to move from this side to the other side. Now what will happen here يا شباب? Now here we are dividing 1 divided by 2 by FL. Now if we decrease if we have low frequency here, if we have low frequency, then we are decreasing the total number here. So if we are decreasing the total number here, XL will increase, XC will increase, right? So we have here impedance, very huge impedance. Now does the current move here? No, because this is very huge now, very huge what? In low frequency, this is very huge impedance. So the current will go from this side to the other side like this. Okay? Now let me just write it down here and you will understand. Now in case of low frequency, this is low pass filter, huh? In case of low frequency, what will happen? Now let us see. We know that XL is going to be decreased, right? And C or XC is going to be increased. And what will happen? Current will go from A to B. So we will have current going from A to B. So our objective is to what, shabab? Is to allow current from A to B. That's why we call it low pass filter. So in case of low frequency, the current will pass from point A to point B. Now in case of high frequency, now let me write it here. High frequency. Now in case of high frequency, now this number here, shabab, this number here, the frequency here will be high, right? What will happen to the total here, shabab? Will be high. So XL will be high. So XL will be more. Now if XL here is increasing, what will happen to the current? It will decrease, right? It will decrease. So it will not allow current like before, right? So it will resist the current. It will resist the current here, right? Now, so it will allow less current, ya shabab. It will allow less amount of current. And what will happen to the XC here, ya shabab? What will happen to the XC if we increase the frequency here? So this total is very huge, right? So the total here is very huge. Then the XC will go down. XC will go down. So it will allow the current to move like if we have current going through XL, which is very low current. So this capacitor, it will trap the current here and it will retain it to the supply. So no current will go from A to B. So no current. No current from A to B. Okay, that's why we call it low pass filter. So in low frequencies, current will go. In high frequencies, current will be stopped. Okay, so in this case, we can draw like this. So in case of low frequency, this circuit will be like this, straight line, right? Here positive, here negative, right? This is A, this is B. Now in case of high frequency, this circuit will be like this. We will have impedance here, right? And the capacitor will act like a trap to retain it to supply. So this is A plus minus. Okay, so in case of high frequency, the capacitor here will act like a trap يا شباب زي الفخ. فالسيجنال السيجنال اللي تمر على الكاباستر راح ياخذ في in case of high frequency راح ياخذه ويرجع لي للسبلاي. It will not allow current to move. So this circuit is called low pass filter. We need it for our buck boost our buck chopper. Now let me draw the buck chopper here. Now let me just small, make it this is small, right? Now okay. Now our circuit here يا شباب, our circuit is like this. This is our let me use the red color. This is our high pass filter, low pass filter, sorry, low pass filter. We said we need it for the buck converter, right? So this is our capacitor here. Of course, if we have a buck chopper, we have output, right? So this is V out here. Now let me draw V out with the blue color. Now this is V out. This is V out. Of course we have V out, right? So this is V out terminal. And of course if we have V out, of course we have load, right? So this is our load. It's just only a resistive load, right? So R. And also we need to add switch. This is our switch. This is switch is a MOSFET. As you know, we know that the MOSFET is like this. This is the gate of the MOSFET. Now this is like a MOSFET, and we have our VN يا شباب. Of course we have VN, right? And we will add something. We will add a contact, a diode here, for our circuit. Now this is our circuit. We added what يا شباب? We added a low pass filter. We added a diode. We added a MOSFET, power MOSFET. We added power MOSFET, and this is VN, and this is V out. VN, of course, we have here plus minus VN. We have, of course, here plus and minus. This is our convention, right? And let's go to see the circuit here. Now, this is our circuit. As you can see here, we have the low pass filter here. This is our low pass filter. And this is our switch يا شباب. This is our power MOSFET, as we explained, either on or off. Now, before we go to on and off, we should explain something very important, which is the signal. Now, the signal of a switch يا شباب, the signal of a switch, as we explained before, this is our signal of the switch. So let me just write the signal. Of course, switch either on or off, right? The switch should be on or off, right? So this is our switch, on, this is on, this is off, here off. This is one cycle, this is on the second cycle, this is off, okay? Now, in order to interpret the waveform here يا شباب, we know that this is on يا شباب, this is on, right? And this is off here. This is on, this is off, okay? And on in digital system, we can say that this is 1, right? And in digital system also, this is, we call it 0, right? And we can say also, this is high input signal, this is low input signal. So high input signal means 1, means on. Low input signal means 0, means off, right? So this is the how to read the signal. Now we need to add also something very important. Let's go back here and let us explain the techniques now. The techniques on how to control the output voltage, how to control the output voltage. Now this is very important, Shabab. Okay. Okay, now we have three techniques يا شباب. We have three techniques in order to control the output voltage. We say that the chopper is controlling DC input to variable DC output, right? So how to control the output? We have three techniques. This is technique number 1, when varying T on while T or the period is fixed. This is called pulse width modulation. Pulse width modulation, right? Now let me draw the signal here and we can interpret the waveform here, شباب. Now this is our signal. We know that this is on switch, شباب. This is off. This is when switch is off. Now this is one cycle. This is again on for the switch and off for the switch here, right? So this is 2 cycles. Now you remember this is called on, right? This is on. This is off. Now we can say here something. We can add something here. We can say this is T on, right? This is T on. The time for on, right? The time for the on switch, for the on when the switch is on. Okay, this is the time. So we can say that the time here, شباب, the time from here to here is T on. Now from here to here, شباب, this is T off. This is called T off, right? Now this is T off. Okay, this is our signal here. This is our signal. This is on. This is off, right? This is on. Of course, this is the second cycle. This is off here. Okay, this is the second cycle. Now we know that this is on switch, right? This is the when we have a high signal, then this is on. When we have low signal, then it is off, right? So we can add something here. We can just add T to indicate the time. So this is the time for the switch to be on, and this is the time for the switch to be off. And to make sure that you understand, so the time from here to here is the time for the switch on. So the time from here to here is the time for switch off. Okay. Now this is, as I said, it is one cycle. So this is one cycle from here to here. This is T. This is big T, right? This is big T, and this is representing the period, or the period. So it is, we will have one cycle per period. Now in this case we have 50% in the period. We have 50% switch on and 50%. This is 50% switch on and this is 50% switch off, right? Now he said here, Shabab, can you follow the mouse, please? The mouse pointer here. So he said the first technique is varying T on and while T is fixed. So we will fix we will fix here, Shabab, the period. So it will fix here. So let me just redraw the signal here, okay? When we are varying T on. Now this is when the duty cycle is 50%. Now you will understand duty cycle. Duty cycle means, if I ask you, if you hear about duty cycle, it means when the switch is on. So 50% is on, okay? Now let me draw the other signal here. If we are varying, if we are varying T on. Now this is our signal. Now if we increase T on, time for on to 75% here, and we will go 0. Okay, and we go again 75, and then we go 0. So as you can see here يا شباب, now T on is bigger than before. This is T on. T off is smaller. Okay, but again, it is they have the same period. They have the same period. See, this is they have the same T. So T1 and T2, they are equal. So T1 and T2 are equal, right? So we are just only changing the T on, يا شباب, the time for on position. So this is duty cycle. When duty cycle is 75%, okay, of the total period. Now we know that the total period T is 100%. Now if we go down from the middle, then it is 50% like this one, right? If we go above the middle, we can reach to 75% and so on. Okay. So this technique is one of the techniques here used, and this is called pulse width modulation. So we have here E, pulse width modulation. This is pulse width modulation, right? This is when T is fixed. Now T is fixed. Now let me just take it here يا شباب. Okay. Okay, now let's go to the second one, يا شباب. The second, varying T while T on is fixed. Now T on is fixed. Now let us bring back the first signal here. This is the first signal. T on is this is T on, this is T off, and here is T on, and here is T off, right? So this is the first signal, right? Now let us see when we are varying T. Now this T is here now. Let me do it here. Now this is T. Now let me vary T now. Yeah. Now for one period we have many cycles. Let's just do it here. So this is on, this is off, this is on, this is off, this is on. Okay, so this is one period. So at one period, see how many cycles يا شباب? Two cycles and a half. Okay, here we have T. So T here is different. T1 here, T2. So T1 is not equal to T2, because T2 should be this is it's not like before. So T1 we said T is for one cycle, so the new T is here. Now let me just do it here for you. The new T is here. So this is the new T from here to here. This is T2. So now T2 is smaller, right? So they are not equal. So this is when we change the frequency. This is why we call it pulse frequency modulation. Pulse frequency modulation, right? This is the second technique. The third technique is basically by changing the T on and T. So we are changing the time for on position. We are increasing or decreasing, and we are increasing the frequency, switching frequency, the switching frequency, so we can change the duty cycle. We say that the duty cycle is what يا شباب? Is when the switch is on. This is when we change the frequency, the switching frequency here. Then we are manipulating what? Time, right? The period. That's why we are changing the frequency, switching frequency. So in the exam, if I ask you to the pulse frequency modulation, what is the pulse frequency modulation? You said you should vary T while T on is fixed, right? And you should, if you answer me with frequency, if you say this is the frequency, I will give you zero. Because in DC system يا شباب, we don't have frequency, right? We don't have frequency. That's why it is not frequency. This is called switching frequency. Switching frequency. This is switching frequency. What do I mean by switching frequency, shabab? Switching frequency means when the switch on and off. Let's say switch on and off for 200 hertz. This is very huge speed, right? So the speed of on and off, this is called switching frequency, right? So this is what we have in the lab. This is what we have in the lab. We are changing the T on shabab, duty cycle. We are changing the switching frequency. We are changing the switching frequency. This is called PWFM, pulse width modulation, pulse width and frequency modulation. Okay, please read this ya shabab to understand, and let me go to our slide here again. Now, in order to analyze this circuit, shabab, to analyze this circuit, okay, as we said, we have, this is our low pass filter here. We have here our diode, we have our power MOSFET switch, we have our load, right? This is our supply, DC, in order to get output DC. Now, in order to analyze this circuit, we need to go for some assumptions. We need to assume something, okay? Now, let me explain for you what do I mean by assumptions. Now, in order to assume something, we need to go for the steady state situations, right? So let us assume, firstly, ya shabab, let us assume that all components, can you see here, ya shabab? All components are ideal. Now, what do I mean by ideal? I mean that the voltage drop here on the diode, shabab, we remember that we said if the diode is made with silicon, then the voltage drop on if the diode is forward bias, then it will be 0.7 volt, right? You remember from electronics. If it is made with germanium, then the voltage drop here is 0.4 volt. Now, we will assume that this is ideal, so there is no voltage drop here. We will assume that the inductive load here is having zero resistance, which is not true, but we will assume that to eliminate all the losses, right? And we will assume that we don't have losses for the switch voltage drop here, shabab. We don't have voltage drop, and if the switch is off, we have Q here, Q voltage. We will assume that all the components here are ideal and we don't have problem with them. Okay? Now, this is the first assumption. The second assumption is this. The circuit is operating at steady state. Now, what do I mean by steady state, shabab? Now, you remember, if we say, shabab, this is our signal. This is on, off, right? So, if the inductor is charging, so it will take time in order to charge, right? So it will go like this: time on, time off, time on, time off, right? So discharge, discharge, charge, discharge. So as you can see here, the time of charging is equal to time of discharging, right? So this time is equal to this time. So this is called steady state. Steady state. We can reach to steady state if we keep the duty cycle 50% in order to have a steady state situation. Of course, in the beginning, ya shabab, in the beginning, if we have, this is the beginning of our system, right? Of course, it will start from here, and then to charge, and then discharge, and then it will start from all to zero, and then like this, shabab. Okay, so at the start we cannot go this is called transient, shabab, transient situation, and here we can call that this is steady state. As you can see here, this is steady state situation. So we need to assume that we will reach to steady state situation. Okay, Now this is the second one. The third one, we need to assume that the inductor current IL is continuous. Means it is always positive. It does not go to zero. Okay? Can you see here يا شباب? Can you see here? The current does not go to zero. Current does not go to zero. This is called continuous current mode, CCM. So we need to assume that the inductor current is in CCM. And CCM means in current continuous or continuous current mode. Continuous current mode. If we say discontinuous يا شباب, DCM, this is means the current goes to zero and we don't need it. Okay, we need current because we need we are asking for steady state, right? So we cannot go for zero and then go back up. So this is not practical, and we will assume that it is in CCM. Now, the third or the fourth one is the capacitor. Now this capacitor, شباب, as you can see here, we need to assume that this capacitor is very large. Why very large, شباب? Because we need the output voltage, the V out, شباب, is held constant at a voltage V out. So if the voltage here, شباب, if the voltage, now let us assume that this is our capacitor is like a tank, right? This is our tank. This is our tank. Now the area here is like the capacitor. The height يا شباب, the height, let me like H, height is like the voltage. Now the volume here, the volume يا شباب, now if the height is here, okay, the volume here should be, the volume should be Q. We know that the capacitor has a formula of Q equal to CV. So Q is the charge inside the capacitor, and this is the capacitance, and this is the voltage. So if we allow current to move to the capacitor, then it will charge a little bit, right? And the voltage will be here. What about the capacitor? It's very huge, right? So it will not affect the V out. It will not affect the V out, and the V out should be always constant. It should be always constant. That's why we will assume that the capacitor is very, very large. Okay? So this is done. Now let's go to the last point here. He said the switching period T on, we should the switching period is T, right? We will assume that. And the switch is closed for a time dt, means that T on يا شباب, T on is basically duty cycle percent multiplied by T. This is when T on. Now in case of T off, he will assume that it is equal to 1 minus the T, right? Now why is that? Now let us concentrate here. This is T on, this is T off, right شباب? Now this is our period. Now basically, as you can see here, this is period and this is half of the period. So T, so the T on is basically duty cycle. How much percent here from the T, right? That's why it is duty cycle percent multiplied T. Now T off, we know that the period here is 1, right? The period is we can consider it 100%, right? That's why we need to reduce 1 from the duty cycle, which is time on, multiplied by T. Okay, so this is our formula. We need to assume that this is our formula for T off and this is our formula for T on. Now please read this paragraph in order to understand more. Now this is again our circuit. This is our power MOSFET, as we said. This is the symbol for the power MOSFET. Now we can draw now the waveform, the output, the voltage for the output voltage and so on. Okay, everything we can draw it here now, but we will make it later. Now let us analyze. Now we already have done the assumptions. Now we will analyze the circuit. Now in case, let's go back here. In case of the switch closed, if the switch is closed here يا شباب, if the switch is closed, then this is like a wire. ولا يا شباب? Now this is like a wire, right? Now what will happen? Now this is ready equivalent circuit. This is the equivalent circuit. Here be the equivalent circuit for the switch closed. Now this is switch here. Let me draw it here. This is switch here. Now here we have diode, but he put it like open circuit. Why is that, يا شباب? Think about it a little bit. Why he put the diode here as open circuit? Okay, now we know that from the convention that we have said that here we have plus from the supply, and here we have minus, right? So if we close this switch here, we will have the same voltage here, right? The same voltage here, right? So this so the anode to cathode voltage, V anode to cathode, is negative, right? Negative. So we will have positive positive from the supply to the cathode, and negative to the anode, which is it will act like, this diode will act like a reverse bias, and then it will act like open circuit. Okay, that's why he put open circuit. Okay, so you can just take a screenshot for my explanation, because I'm going to erase it. Okay, خلاص. So we know that this is our diode. It looks like open circuit. Now, this is when switch is closed, right? When this switch is closed, let me do it like this. This is our switch. It will in case of closed switch. Now we know the operation of the electronic switch is on and off, on and off, on and off simultaneously, and now we are analyzing the circuit when the switch is closed. Now what will happen? Now we know that the voltage, the current will go from here through the L here, the inductive load, and we will have voltage here, positive, negative, right? And then we will have and the inductive load is going to charge, right? And of course also we will have current going through the capacitor, which is called IC, and we have current going here, which is, we can call it I out, and we have voltage here, positive, negative, right? Now if we analyze this circuit and we can do KVL يا شباب, Kirchhoff voltage law, what should we have? Now I'm going to do it with another color. Now this is plus minus here, right? Now of course this is parallel V out على الكاباستر over the capacitor, so we will have here what? Plus minus. Now again also we have switch closed here, so we have here plus minus. Now doing KVL, what will have? We will have that the VS is equal to what? Equal to VL plus V output, right? So we can say this is VL plus V out. Now in order to find VL by itself, we can say that it is VS minus V out. Now VL, we know that VL, what's the VL here شباب? VL is basically L multiply di of L of T divided by dt. What do I mean by this شباب? This is L, the inductive load, and this is the derivative of the current, because we know that the current is changing, right? Charging and discharging. So it will be like a derivative here, term. So di, the current derivative, right? And if we multiply the current derivative by L, we have VL, right? This is from Ohm's law. Okay, شباب? Now we can find di by dt here, شباب. We can check it out. So di L of T dt is equal to what, شباب? Equal to Vs minus V out divided by L. Divided by L. Now this is the equation that we need. to understand يا شباب. Okay, so I'm going to take it here يا شباب, and I'm going to erase it because this formula is this one يا شباب. خلاص. Okay, this is the one, so I'm going to erase it. Now in order to analyze this circuit we need to go for the final result. صح ولا يا شباب؟ so let us concentrate. I'm going to drive now and we will see how to get as output يا شباب. Now make sure that you understand this is at steady state condition. Okay. طيب now in this case what should we have? Okay, now we know from this formula يا شباب, can you see this formula? We know that this value here is constant. صح ولا شباب؟ is a number, right? So this is constant and L here also is constant. So the rate of change of current, what will happen to the rate of change, charging and discharging? It will be constant, right? راح يكون linear ولا يا شباب؟ So it will be linear, so it will be constant. So that's why when I say derivative of the current means it is either charging or discharging. Okay, so it is the rate of change of the current. So this is the rate of change, and as we said it is linear. Okay, this is linear. We should know the slope. The slope of what يا شباب? Of the rate of change of the current. Now of course this is the change of the current. What will happen يا شباب? The slope is basically Vs minus V out, right? And we know that this changing it happens with time. So this is time, this is slope. Okay, the slope is given. This is the slope, and we know the time يا شباب. And what should I have? I should have here يا شباب delta I of L. Now what do I mean by delta I of L? هو مقدار الزيادة بالعربي. مقدار الزيادة, it is the amount of increasing the current, the amount of increasing or decreasing, right? So we need to know the amount, because this one is constant as we said and this one is constant. So we can find by mathematics that we can find delta IL. Now this delta IL, it happens لأن charging صح شباب. It happens when what يا شباب? When it is close. So we can say this IL when close. Delta IL when close, right? Okay, now let us just remind you with T on and T off يا شباب. Now this is T on, this is T off. Now T on is basically duty cycle multiplied by T, right? T off is 1 minus duty cycle multiply T, right? Now when the switch is closed means I need what يا شباب? When the switch is closed means the switch is on, right? We need to find the change of the current, مقدار تغير الكرنت in what يا شباب? When the switch is closed, right? So in order to find it, we can write here like this يا شباب. Delta I close, okay, is equal to what? Is equal to Vs minus V out divided by L, okay, multiply by DC, multiply by T on, صح? Multiply by T on. Now delta IC is equal, closing mean, Vs minus V out divided by L multiply duty cycle percent multiply T. So this is our formula when the time is closing. So we analyzed the circuit and we found that the time for closing, this is our formula. Okay, for the formula. Now at steady state يا شباب, at steady state we should know that delta I close plus delta I open is equal to 0. This condition is correct. So when we have the charging of the inductor is equal to discharge of the inductor, then we will have they will add together. Okay, add together and it will be equal to 0, right? Okay, if we go for the open switch here now, we are going to analyze this circuit, okay, again, but I'm going to do, I'm going fast here, okay? So this is when the switch is off, when the switch is off, when the switch is open, right? Now what will happen here, شباب? Now if this one is open, so there is no Vs, right? There is no Vs because we have open circuit, right? Now, this is the old convention, right? This is the old convention. Now, what will happen to the inductive? It will, what يا شباب? It will discharge. It will discharge, so the polarity will be flipped, right? Now, again, here يا شباب, from the previous convention, we know that this is V out, this is plus here minus, so we will have the same thing here, right? Now, if we apply again KVL, we have two voltages, V out and VL. They are opposite to each other. So VL is equal to minus V out, okay? Because we have positive here, so they are the voltage of the output is negative. The voltage is output is negative now, okay? So this is our convention. Now what will happen here, شباب? Now, as you can see here, يا شباب, as you can see here, if you could see here, يا شباب, now we have diode as what, يا شباب? As a short, as a closed circuit. Why is that? Because we have now the positive here, the negative here, and the positive here, right? So we will have negative here, we have positive here, then we have closed circuit from here. It will be the voltage for V and to cut it will be positive. Then we will have forward bias. Then the current will go like this. The current will go like this. This is for the discharge time. So when the T is off, okay. So again, we know that VL is equal to L di over dt. And we can conclude that dI L over dt is equal to minus V out over L, right? This is when the switch is open. Now, we will multiply this value by what, يا شباب? By T off, right? Remember, T off is 1 minus D duty cycle multiplied by T. So the output or the delta I, the rate of change of the discharge, شباب. Now we are talking about the discharge. Discharge, we know the slope. The slope is ready because the slope is basically is minus VL, minus V out over L. So the slope is constant. And at the time here, we know the time. And this is delta IL open, IL opening, okay? Now, delta IL opening is basically minus V out over L multiplying 1 minus delta duty cycle T, right? So this is our formula here. Now, if we apply, now we know that this is at steady state condition, right? We know that this is at steady state condition. We can add them together in order to get 0, right? So we can add them together now. Now let me write it here يا شباب. let me write it here. So delta I L closed is basically Vs minus V out divided by L multiplied by duty cycle, right? Duty cycle percent multiplied by T minus V out, because this is we have here minus, right? So minus V out over L minus V out over L 1 minus duty cycle percent multiply T equal to 0. So this is our formula. Now we can see that we have common factors. We can remove them. So this is common here, so we can remove them, and L here is common, so we can remove it. Now what do we have here يا شباب? Now we have Vs duty cycle percent minus V out duty cycle percent. Now here we have minus V out, yes, minus V out plus V out duty cycle percent is equal to 0. Now again we have common things here, so we can remove. This is plus V out DC, and we have here minus V out DC. So what should we have يا شباب? Now the remaining is يا شباب, the remaining is Vs DC minus, now we can take the V out, yeah, we can take the V out on the other side. So this is V out is equal to Vs multiply DC. So this is our formula. Now we can conclude that in chopper buck يا شباب, buck, in buck, we can conclude that this is the formula. V out is equal to V in or V source multiply duty cycle per percent. So if we have input voltage is 100 and the duty cycle is 0.5%, 0.5, okay, so how 50%, so the V out will be 50 volt. That's why the voltage is dropped. That's why the voltage is dropped يا شباب, okay. Yeah, this is all about our buck converter. So we drive the equation for the buck chopper converter. Now let's go back to the waveform here and draw the waveform يا شباب. Now let us do it together. So this is our waveform. This is our circuit here. As you can see here شباب, this is our circuit. Again, we can analyze now the output, everything here with the switch on and off and so on, okay. So let us just only write down or draw the waveform for the switch, right, for the gate signal. This is called V gate, the voltage signal. So we need the duty cycle is 50%. We need the duty cycle is 50%. So we can draw it here. I'm going to use the same color. This is the duty cycle. So the duty cycle here is 50% on, 50% is off, 50% is on, 50% is off. So this is 2 cycles. Plus, this is 2 cycles. This is enough. Now let's go to Vs, right? Now Vs is used with this color. Now, when the switch is closed, okay, now Vs will be here, right? So we have Vs. When the switch is off, we don't have a Vs. Let me draw it here. When the switch is off, so we don't have voltage here, right? In this part, Now, because this one is open circuit, we don't have voltage. So basically it follows the power MOSFET switch. It follows the power MOSFET. When this switch is closed, we have voltage. When the switch is open, we don't have voltage. That's it. Okay, so it is the same as the so it will be high here and it will be low here. It will be high here and it will be low here. Okay, so it will follow what يا شباب? It will follow the switch, the switch يا شباب. If the switch is on, we have voltage. If the switch is off, there is no voltage. Okay, now what about I out? Now let us think about I out first. Now as you can see here, let us close the switch first with the blue color, huh? If we close the switch here, then we have voltage here. Then this one is reverse bias, right? Because this one is different now. And then what should we have here? We have current going from the supply to the inductive load. The inductive load is charging, right? And also it will allow current from the supply. The supply will go from, it will charge the inductor, and also it will go through IC and IR. So as output, IR is our output. IR is, we can say it is our output because it's across the load, right? So we can say it will charge like this when the switch is on, right? When the switch is on, we can say it is charging. So that's why we are going to use the red color here. Now we can say it is charging like this. Okay? Now when the switch is off, with the yellow color here يا شباب, or the orange one, when the switch is off, there is no voltage here, right? What will happen to the inductive load here? What will happen? The inductive load is going to discharge its current to the capacitor and the load. So it will discharge. It will discharge and it will come like this. It will be rotating like discharge. Okay, so it will go down, right? So it will go down like this, but then it go up, then it will go down. So this is the waveform for the I out. This is the waveform for the I out. Now in your theory يا شباب, in your theory questions, or in the questions يا شباب, you will be asked on something very important. This is called I maximum for the output. You have formula. You can find it in the last slide here يا شباب. And this is something called I minimum. So we need to calculate it to find what يا شباب? The rate of change of the current, right? So this is the output current. Now let's go to IQ. Now when I say Q, I mean that يا شباب, I mean about, now IQ here is basically the Q here, the power MOSFET, the current through the MOSFET. Now if the switch is closed, we have current, right? Of course, if the switch is open, we don't have current. As simple as that. That's why we will draw current here. This is IQ. So this is IQ, right? When we have when the switch is closed, we have current. When the switch is open, we don't have current. That's why we will go 0, right? We don't have discharge current. We don't have current يا شباب at all. Okay. Then we will go. I will go up charging. Current going through, and then 0, like this. So this is IQ. This is IQ, right? And we know that basically IQ here through the switch here, IQ is the same as the I source. So if we have switch is closed, then we have current through the power MOSFET, and it is the same current for the I source, right? So this is the same thing. And we can add here, so it will be the same thing here, right? So it will be the same thing. Now let's go for the current through the diode. Now let us understand the current through the diode now. Now, as we said, if the switch is closed, then this one is open circuit, right? Because the voltage here will be positive and here negative, so this will act like a reverse bias, right? If the switch is open, this is going to be our supply now, and it will discharge the current like this. So the current will go through diode. So if the switch is closed, okay, then we have open circuit. So this is open circuit. This is open circuit. We don't have current. If the switch is open, then the discharge current will appear, right? Because we have inductive load is discharging, so the current of the discharge will be like this. Then we'll go down like this. Then we'll go up like this. Okay, and we'll go down. Okay, so this is our signal. Okay, this is I diode. Now, of course, if we have current in the diode, then there is no voltage, right? If we have current, means it is like a wire, then we don't have voltage, right? Yes, we don't have voltage. That's why we have here 0. If we have current, we don't have voltage, because it will act like short circuit or closed wire, or it will act like a wire, so there is no voltage. If we don't have if it is open, if it's reverse bias, if the switch is closed and the diode is reverse bias, then we will have what is negative voltage. Of course, we will have our negative voltage. Okay. Okay, this is the V diode. Now, the VQ, this is the voltage across the power MOSFET, is basically when the switch is closed, it will act like closed wire. So it is like a wire, so there is no voltage. So this is when the switch is closed. It will act like a wire. Now, if the switch here is open, then we will have a voltage VQ, right? So, and VQ should be positive. So it will be positive like here. And it will be like here. Okay, so this is our VQ. Now we finished, alhamdulillah, the analysis. Now let us just only change the VS here, or the duty cycle, to 75%, and let us see what will happen. Okay, let us see what will happen. Now this is VS, so what will happen, shabab? So the voltage, when the switch is closed, we will have voltage, okay? Yeah, we will have a voltage for 75%. So this is up to here is 50. This is almost 75%. And the rest is 0. Then we will go up for 75%. Then we'll go 0. So this is our VS. Now let us use I out. Let us see the I out here, shabab. I out, we can use another color. This is, sorry, I out. Okay, so I out is charging for 75% and discharge for the rest. 75% charging, and discharge for the rest, and so on. Okay, so the time for charging is more now. The time for charging is more. This is for 75. If it is 25%, so the time for charging is more. The time of charging is less. The time of discharging is more, and so on. Okay, so this is the concept for the buck chopper. I hope that you understand. Let's just go to the formulas. These formulas is needed for the exam, ya shabab. You can find them in your textbook. So I brought all the equations that you need for your calculations here, ya shabab. This is when you need I maximum. This is when you need I minimum, as I explained. Now this is when this is when the how to calculate L, the minimum L that you can get for continuous current, and this is B out, and we can take from this formula that I out is basically I S multiply duty cycle percent. So no, it should be IS here, IS here, I out. We know that the VS, VS is basically, now I don't want to confuse you. Let me just do the first one and then go for the next one. Now we know that V out is equal to, for the buck, shabab, we know that it is VS multiply duty cycle, right, percent. Okay, now the current from here, it should be opposite because we need the same power, right? So we cannot just enter give power and expect more power than we give. Okay, this is wrong. The concept is wrong. The B out is always equal to BS. B out cannot be more than BS. Okay, so here the I out, or yes, the I out is of course is opposite. So let me just do here, not to confuse myself. IS is equal to I out multiply duty cycle. So I out is basically IS divided by duty cycle percent. So can you see, shabab? Now this is the opposite. So if we decrease the voltage by the buck, shabab, we should increase the current in order to make P out is equal to Pn. Okay, now this is from a machine, shabab. This is from machine one. You should understand it, and this is the basic concept for transformers. It is the same principle here, shabab. The same principle here. Now you can refer to the book here to understand those formulas. Okay, let's go for the example here. This is example 6-1 in your textbook. If it is giving you the buck DC converter has the following parameters. He gave you the VS, duty cycle, L, C, F, and R. And in order to find the V output, we can just only apply the formula. This is very easy formula. VS multiply duty cycle. Duty cycle is 0.4. Now he wants you to find I maximum and I minimum. So you can just apply the formula and you will find the answer. Here he said the output voltage rebel. We know that this is the output voltage rebel, right? Okay, this is output voltage rebel. So we can find by applying the formula in order to find the output. Now this is one example. You can refer to this video for more examples. Okay, now this is all about our lecture today. Thank you so much for attending this lecture. I'm going to send you the notes for this lecture as slides. You will find it there, inshallah, with all my notes. Thank you so much for attending this lecture, and stay safe.